Overview. The primary flight controls on the Avro RJ are ailerons for roll control, elevators for pitch control, and a rudder for yaw control. Ailerons and elevators are controlled mechanically by servo tabs. The rudder is controlled hydraulically. Additional roll control is provided by hydraulically powered roll spoilers. All three primary controls can be independently trimmed to assist the flight crew in maintaining straight and level flight. A stall warning system warns of an impending stall. If a stall condition is allowed to develop, a stall identification system pushes the control columns forward. The secondary flight controls on the Avro RJ are flaps, air brake, and lift spoilers. The flaps and lift spoilers are hydraulically operated by both systems. The air brake is operated by the green system only. The next lesson will take you through a general description of the components and operation of the primary flight controls. Roll control. Roll control is provided by ailerons and assisted by hydraulically powered roll spoilers. The ailerons are operated by servo tabs, which reduce the effort required by the pilot. The aileron servo tabs are controlled by two interconnected circuits. The pilots normally have control of both of these circuits via the hand wheels. There is no direct connection between the hand wheels and the aileron surface. The two hand wheels are connected under the flight deck floor by a collapsible strut. Additionally, both aileron surfaces are interconnected to ensure that they always move in opposition. Artificial feel in the aileron circuit is provided by a spring strut in the left-hand circuit, which increases the load on the hand wheel as the pilot's input increases. Aileron disconnect. In the event of a mechanical jam in one of the aileron control circuits, they can be disconnected to allow reduced roll control from the free circuit. The aileron circuits are disconnected by forcefully rotating the hand wheels. This causes the collapsible strut that connects them to break into two, one part sliding within the other. This, in turn, will electrically signal the aileron disconnect device to release. This is fitted between the two ailerons and, once released, will allow them to move independently. Once the disconnect device has released and the two ailerons are disconnected, the amber aileron elevator uncoupled annunciator will light on the central warning panel. A T-handle on the center pedestal is provided, which sends an additional disconnect signal to the aileron disconnect device. The T-handle is fitted as a backup to the signal from the hand wheel connecting strut. A mechanical interlock on the T-handle prevents it from being operated inadvertently. Once the aileron circuits have been disconnected, they cannot be reset until after flight. Following a disconnection of the aileron circuits, why is the aileron disconnect T-handle pulled? Roll spoilers. Roll spoilers, powered by the yellow hydraulic system, are used to assist the ailerons by destroying lift on the downgoing wing. They deploy with the upgoing aileron and are signalled mechanically from the servo tab's control cable. Indication of roll spoiler deployment to a maximum angle of 10 degrees is shown on two gauges mounted above the central warning panel. To prevent unnecessary spoiler movement, they do not deploy for small control inputs. However, they are fully deployed before the control wheel reaches full travel. Aileron trim. Each aileron is fitted with a trim tab, mechanically operated from a wheel on the center console. Trim position is indicated in a window above the hand wheel. The neutral trim position is achieved when both the marker in the window and the marker on the hand wheel are aligned. Aileron trim must be in the neutral position before takeoff. That completes our look at the components and operation of surfaces to achieve roll control. Next, we will cover pitch control. Pitch control. Pitch control is provided by mechanically powered elevators operated by servo tabs. The elevator servo tabs are controlled by two interconnected circuits. The pilots normally have control of both of these circuits via the control columns. There is no direct connection between the columns and the elevator surfaces. The two control columns are connected under the flight deck floor by a mechanism. The two elevator surfaces are not connected. Elevator disconnect system. In the event of a mechanical jam in one of the elevator control circuits, they can be disconnected to allow reduced pitch control from the free circuit. This is achieved by forcing the columns in opposite directions, which causes their connecting mechanism to split. However, unlike the aileron circuit, if the columns are realigned, the strut will reconnect. The columns can be prevented from reconnecting by pulling the T-handle on the center pedestal, which opens a mechanical clutch, permanently separating the two columns. When the handle is pulled, a mechanical interlock operates, which prevents the handle being inadvertently reset. When the clutch is open, the amber aileron elevator uncoupled annunciator will light on the central warning panel. The elevators can be reconnected in flight by realigning the control columns and resetting the T-handle. Following an instinctive breakout of the elevator circuit, why is it important to pull the elevator pull-disconnect T-handle? Artificial feel systems. Artificial feel in the elevator circuit is provided by a pneumatic Q feel system in the left-hand circuit and a G weight in the right-hand circuit. The G weight uses a mechanical weight to increase the load on the control column as G loading changes. The Q feel system uses pitot air pressure to increase the load on the control column as airspeed increases. A failure of the Q feel system is indicated by the amber rudder elevator Q fail annunciator on the central warning panel. Both field systems are normally in operation because the two control circuits are normally connected. Following an elevator disconnect due to a control jam, only the field system in the unjammed control system will be available. If a jam is detected in the first officer's elevator control circuit, what artificial field systems will be available? Elevator trim. Each elevator is fitted with a trim tab, which can be operated either mechanically or electrically. Trim can be applied mechanically from a pair of interconnected wheels either side of the center console. Trim position is indicated in a window in the middle of the center console. Pitch trim must be within the green band before takeoff. Both trim tabs can also be electrically driven by a trim motor located in the tail. Aircraft fitted with two flight guidance computers have an additional trim motor fitted in the tail. However, only the trim motor associated with the selected computer will operate. The trim motor can be controlled either manually by thumb switches on each pilot's hand wheel or automatically from the flight guidance system. The manual trim switches comprise two parts. Both must be operated in the same sense to achieve changes in trim. Trim switches are inhibited when the autopilot is engaged. The flight guidance system can automatically trim the aircraft in pitch during flight. This is indicated by movement of the pitch trim hand wheels. Additionally, to compensate for large out-of-trim forces on the control columns during flap movement, the RJ uses flap trim compensation to give nose down trim as flaps are extended from 0 to 18 degrees, nose up trim as flaps are retracted from 18 to 0 degrees. Flap trim compensation is a function of the flight guidance computer and operates automatically, irrespective of whether the autopilot is engaged or not. It is inhibited on the ground and above 18 degrees flap angle. A failure of flap trim compensation is indicated by an amber flap trim compensation indication on both pilots' instrument panels. Gust dampers. Gust dampers are fitted to the elevators and ailerons to protect the control surfaces when the aircraft is parked. They are self-contained and operate automatically. They work by preventing very fast movement that would cause damage to the controls, which could occur when the aircraft is parked with a tailwind. In flight, the gust dampers will not restrict pilot control inputs. No control surface locks are fitted. However, a control column restraint is provided. To complete the pitch control system, the next section will take you through the RJ stall warning and identification system. Stall warning and identification system. The RJ is fitted with a two-stage stall warning and identification system. The system uses two angle of attack sensor vanes mounted either side of the nose, together with flap angle and airspeed, to calculate how close the aircraft is to a stall condition. The first stage of stall detection is known as stall warning. At a predetermined angle of attack, this results in stick shake, where both columns are vibrated by electric motors. If the angle of attack increases beyond this point, the second stage of stall detection will operate. This is known as stall identification and results in stick push, where both control columns are forced forwards by a pneumatic ram to reduce the angle of attack. Both stick shake and stick push will be maintained until the angle of attack is below the stall warning trigger point. The two systems are inhibited on the ground. Stall warning is available immediately on takeoff, but stall identification is not available until 6 seconds later. Air pressure to the ram is supplied from a stall air reservoir, which is continuously charged by bleed air fed directly from engines 2 and 3. Should this bleed air supply fail, indication is given by the stall air low pressure annunciator on the air supply panel. In this case, the reservoir will hold sufficient air pressure for 3 stick push operations. Where is air pressure to the stall air reservoir normally supplied from? Stall warning. Stall warning is signalled from 2 warn units. Each is connected to one angle of attack vane. If either warn unit detects an angle of attack greater than its trigger point, it will operate both stick shake motors. The ground proximity warning system will be inhibited during a stick shake. Stall identification. Stall identification is signalled from 2 identification units. Each is connected to one angle of attack vane. It is important to note that the warn and identification units are connected in 2 channels. The 2 units in a channel do not take their angle of attack input from the same vane. This ensures that a single vane is not capable of producing a stall identification. If either identification unit detects an angle of attack greater than its trigger point, and provided that its associated warn unit has operated, an automatic stick push will occur. Stick shake will also be operating. When a stick push is signalled, two pneumatic valves open, directing air from the stall air reservoir to a pneumatic ram underneath the flight deck floor. The stall valve annunciators are located on the left and right instrument panels. If either identification unit detects an angle of attack greater than its trigger point, and its associated warn unit has not operated, a fault indication will be given. This is an amber stall identification indication on the central warning panel, and two identification 1 or identification 2 annunciators on the instrument panels. The faulty stall identification unit may be inhibited by pressing its identification push button. If this is done, inhibit will illuminate, and the system cannot be reset in flight. The entire stall identification system can be inhibited at any time, for example if an uncommanded stick push occurs. Both ident push buttons should be pressed simultaneously. When the stick push is operating, what flight deck indications are present? That completes the stall warning and identification system. To finish this lesson on primary flight controls, we will look at yaw control. Yaw control. Yaw control is provided by a hydraulically powered rudder. Two hydraulic actuators mounted on the fin are signalled mechanically from the rudder pedals through a single control circuit. One actuator is powered by each hydraulic system, and under normal conditions the two actuators work together. However, if one should fail, the remaining actuator is capable of operating the rudder, although at a slower speed than normal. Each actuator is fitted with a microswitch, which can signal either a mechanical jam of the actuator or, on the ground only, a loss of either hydraulic system. This will be indicated by a rudder valve annunciator on the central warning panel. Artificial feel is provided by a spring strut, which increases load on the pedals as they are moved. A Q limiter system decreases the amount of rudder travel available as airspeed increases. This prevents overstress of the aircraft at higher airspeeds. A failure of the pitot-static supplies to the Q limiting system is indicated by the rudder elevator Q fail annunciator on the central warning panel. However, if the Q limiter remains engaged below 160 knots, full rudder travel will not be available when it is most needed. This is indicated by a rudder limiter warning. What is the purpose of the rudder limiter? Rudder trim. No rudder trim tab is fitted. Trim is applied by offsetting the rudder. A trim wheel is fitted on the center console. Trim position is indicated in a window above the hand wheel. The neutral trim position is achieved when both the marker in the window and the marker on the hand wheel are aligned. Rudder trim should normally be in the neutral position before takeoff. Rudder trimming is only available when the hydraulic systems are pressurized. The trim hand wheel operates two screw jacks. One repositions the hydraulic actuators, which then reposition the rudder. The rudder pedals are offset when trim is applied, so a second screw jack recenters the rudder Q limiter to maintain equal pedal travel around the new trim position and recenters the rudder pedals. That completes our look at the primary flight controls. The next lesson covers secondary flight controls. Flaps. The flaps are driven by screw jacks from a single drive shaft on each side. The drive shafts are driven by two hydraulic motors through a gearbox. One hydraulic motor is driven from each system. This allows the flaps to operate at half speed following a hydraulic failure. The motors are signalled electrically by the flap selector lever on the flight deck through a flap computer, which is located in the avionics bay. A single lever is fitted on the flight deck for flap selection, and a flap angle gauge is mounted above the central warning panel. External indication of flap angle is given by the markings on the inboard face of number 2 pylon. Flap control. The flaps are signalled from a lever with 5 selectable positions. The 18 and 24 degree positions are balked to aid their selection and to ensure that flap up or flap 33 cannot be selected by mistake. A mechanical balk is automatically applied to the lever in the flap up position above 227 knots airspeed. This prevents inadvertent flap selection at high speed. If it fails to release below this speed, it can be released manually by pressing the flap balk override button. The signal from the flap selector lever is sent to the flap computer, which in turn signals the 2 hydraulic motors. The flap computer comprises 2 control lanes and 2 safety lanes. Control lane 1 controls the yellow hydraulic motor. Control lane 2, the green. Each control lane is capable of operating the entire flap system. If both are operational, the flaps will run at normal speed. If a control lane fails, the remaining control lane will operate the flaps at half speed. The two safety lanes monitor the operation of the system and provide fault protection. Safety Lane 1 provides protection against flap asymmetry and provides flight recorder and flap position information. Safety Lane 2 is provided as a monitor of both control lanes. Each safety lane is capable of disabling either one or both control lanes, depending on the severity of the fault. A minor fault in the system will be indicated by a flap fault indication on the central warning panel. The flaps will still be operable, although possibly at half speed. A more significant fault will be indicated by a flap inoperative indication. In this case, the flaps will be locked in position and will not be available until reset on the ground. To protect against flap asymmetry, the flaps will be locked in position before a 2-degree difference is exceeded. Asymmetry brakes use yellow system hydraulic pressure to lock the flap shafts in position and are available to the essential power level. It is important that flaps are operated correctly, otherwise a flap fault warning could illuminate. On the ground, this may be cleared by following a flight deck reset procedure. If this is unsuccessful, maintenance action is required. Any of the following will give a flap fault. The flap lever is not in the correct position when the battery is switched on. Making flap selections with either hydraulic system depressurized. Making flap selections with any flap circuit breakers open. Making flap selections whilst switching power supplies. Not engaging the flap lever in a gated position or moving it too slowly. Under which conditions would the flaps travel at half speed? Any fault within the flap system will be indicated by a fault code on the front face of the flap computer. To assist with maintenance, it is recommended that a note of this code is made before attempting a flap reset or depowering the buzz bars. Note that the flap reset procedure can only be attempted on the ground. That completes our look at the flaps. We will now move on to the air brake. Air brake. The air brake is fitted at the rear of the aircraft and forms the fuselage tail cone when fully closed. It may be operated at any altitude or airspeed with no restrictions. It can be opened to a maximum of 60 degrees either side of center and is hydraulically powered by a green system actuator. The actuator is controlled by an electrically signaled valve. The valve is controlled by a lever on the center console, which allows selection of any air brake position from fully closed to fully open. This lever also allows manual selection of lift spoilers on the ground when taken beyond the gate at the fully open position. No indication of air brake position is given other than a white air brake annunciator on each pilot's instrument panel. These illuminate if the air brake is in any position other than fully closed. If electrical power to the valve fails when the air brake is open, it will be closed by hydraulic pressure. Alternatively, if hydraulic power fails when the air brake is open, it will be pushed by the airflow to a minimum drag position, but will not fully close. The air brake annunciator will remain lit. If the air brake is open, it will automatically close as the thrust levers are advanced to a takeoff setting. For example, during a go-around. However, the flight crew must select the air brake in to prevent it opening automatically when the thrust levers are retarded. To finish this lesson on secondary flying controls, we will look at lift spoilers. Lift spoilers.
The lift spoilers comprise 3 panels on the upper surface of each wing and are used to destroy lift after landing.
The spoilers are powered hydraulically, the inner panels from the yellow system and the centre and outer panels from the green system. They are signalled electrically from the flight deck, either manually or automatically, and are inhibited in flight. Manual deployment is used as a backup to automatic deployment. 3 control switches are fitted on the lift spoiler panel: auto spoiler, lift spoilers yellow, and lift spoilers green. In order to prevent the spoilers deploying any time other than after landing, the aircraft must be weight on wheels with at least 3 thrust levers at or below idle. The lift spoilers will deploy when either the manual or auto selection conditions are met. Manual lift spoilers. Both the manual spoiler control switches must be selected on for manual spoiler deployment. If either is selected off, lift spoiler selected off will light on the central warning panel. To deploy the lift spoilers manually, the air brake lever must be moved through a friction bulk to the lift spoiler position after landing. To protect against spoiler deployment in the air, what are the conditions for spoiler deployment? The yellow spoilers will deploy immediately lift spoiler is selected. The green spoilers will deploy after both the main gear have been weight on for 1.5 seconds. Auto lift spoilers. Automatic deployment requires all 3 spoiler control switches to be selected on. If the auto spoiler switch is not on, a white auto spoiler off annunciator on the central status panel will be lit. If the conditions for lift spoiler deployment are met, the yellow spoilers will deploy immediately. Auto spoilers are signalled. Auto spoilers are signalled when a wheel speed of 33 knots is reached, or if the runway is contaminated 5 seconds after touchdown. The green spoilers will deploy after auto spoilers have been signalled and both main gear have been weight on for 1.5 seconds. As a backup to auto spoilers, it is recommended that a manual spoiler selection is always made after touchdown. All spoilers will retract when the aircraft slows below 15 knots, and the air brake lever is forward of the lift spoiler position. Lift spoiler indications. When hydraulic pressure is supplied to the spoiler actuators, 2 green spoiler yellow and spoiler green annunciators will light on the instrument panels. If no other indications are shown after 6 seconds, successful spoiler deployment has been achieved. Failure of one or more spoilers to deploy is indicated by 2 amber lift spoiler annunciators on the glare shield. These alert the pilot to check that a lift spoiler selection has been made, or to be aware that braking distance may be increased by up to 40%. The lift spoiler annunciators can be extinguished by pressing either of them, or after 14 seconds they will go out automatically. Lift spoiler fault indications. The lift spoilers use duplicated control signals to improve their fault tolerance. If the 2 signals in either system disagree, an amber, yellow fail or green fail annunciator will light on the overhead lift spoiler panel. This indicates that the affected system has reduced integrity and must be switched off. A failure of the auto spoilers is indicated by an amber auto spoiler fault warning on the lift spoiler panel. Auto spoilers must be switched off. The warning is replaced by a white auto spoiler off indication on the central status panel. Each lift spoiler actuator is fitted with an internal mechanical lock, which is only released when it is supplied with hydraulic pressure. This lock is designed to prevent a spoiler from rising into the airflow if a hydraulic system fails. If the lock fails, spoiler unlocked will light on the lift spoiler panel. This warns of possible handling problems. The integrity of the weight-on-wheels system is continuously monitored. Any error between the weight-on-wheels signals will light manual spoiler fault on the lift spoiler panel. In flight, care must be taken not to move the air brake selector lever into the lift spoiler position. Which of the following controls are powered only by the yellow hydraulic system? That completes our look at the secondary flight controls, flaps, air brake and lift spoilers. The next lesson covers the configuration warning system. Configuration warning system. The configuration warning will light and an intermittent horn will sound if any of the following conditions exist when a takeoff is attempted: air brake not fully closed, lift spoilers not locked down, flaps not in a takeoff setting, elevator trim not in the green band, aileron trim not in the neutral position, park brake not released. The warning will occur as the thrust levers approach the takeoff position. The warning cannot be cancelled by pressing the attention getters. The thrust levers must be retarded to idle. The aircraft configuration may be checked before takeoff by pressing the Configuration Check button on the center console. Having looked at the configuration warning system, next we will cover the external aircraft checks. External checks. External checks are carried out in a clockwise direction from the nose of the aircraft. Angle of attack vanes and the Q-pot head are checked. The aileron, trim and servo tabs, flap and track fairings, elevator and tabs, tailplane and rudder, and the air brake are checked. The left-hand side of the aircraft is checked in a similar manner, but in addition, the position of the flap should be noted by the markings on the number 2 engine pylon. That now completes the external checks of the aircraft. The next lesson covers normal operations. Pre-flight. At the start of the flight deck safety checks, the air brake lever is checked to ensure it is fully forward, and the white air brake annunciators are out. The flap lever position should agree with the position noted during the external checks. Note that the flap indicator gauge reads below 0 when it is not powered. This should not be used to confirm flap position at this point. After the batteries have been switched on, auto spoiler, lift spoilers yellow and lift spoilers green should be selected on.
Once the AC bus bars are powered, the stall warning and identification system is checked by pressing each of the 4 test buttons on the ground test panel. Each button simulates an angle of attack above each unit's trigger point.
Pressing and holding the Stall Identification 1 button will operate the identification unit without operating its associated warn unit. The Stall Identification and Identification 1 indications will light after a short delay. When the button is released, the indications should clear. The test is then repeated for Stall Identification 2. The operation of the stick shakers is checked by pressing and holding Stall Warn 1. Both stick shake motors should operate. The test is repeated for Stall Warn 2. The Stall Warn test buttons will operate in flight, but the Stall Identification test buttons are inhibited.
The flap system should now be tested using 3 test buttons on the ground test panel. These buttons check the integrity of the 2 control lanes and safety lane 1 only.
Safety lane 2 can only be checked during ground maintenance.
All 3 test buttons are inhibited in flight.
The flap safety test button is pressed and released when flap inoperative lights. It should go out to confirm that safety lane 1 is serviceable. The flap control fault yellow test button is pressed and released when the flap fault annunciator lights. It should go out to confirm that control lane 1 is serviceable. The procedure is then repeated for flap control fault green to check the integrity of control lane 2. Full movement and indications of manual trim is now checked. Both hydraulic systems should be pressurized before checking the rudder trim. Rudder and aileron trims are then set to the neutral position. Operation of the electric pitch trim is checked by pressing the two trim switches on both hand wheels in both directions and checking that the manual trim hand wheels and the trim indicator move. Elevator trim is then set from the trim sheet in preparation for takeoff. The two halves of the electric trim switches must not be operated in different directions. This may cause a white flight guidance system advisory and an elevator trim warning. The aileron and elevator disconnect handles should be in, and the aileron elevator uncoupled annunciator out. After engine start, the required flap setting is selected, and the indication on the flap gauge checked to confirm it is correct. Elevator trim is checked with the trim sheet, and the aileron and rudder trim checked for neutral position. The configuration check button is pressed and held to check that no warning is given. Finally, the ailerons, elevators and rudder are checked for full and free movement. The elevators must be moved throughout their full range to ensure that any accumulation of water inside the elevator is allowed to drain. It is important to remember that with a servo tab control system, a partial movement of the control column will not ensure full movement of the elevator, as only the servo tab is connected to the control column. It is necessary to apply full control column movement to ensure that the tab picks up the elevator and then with increasing control force moves the elevator to its limit. This check is normally only achievable with the aircraft into the wind, as tailwind loads prevent the pilot from overcoming the high elevator forces. After completing these checks, the control column must be held in the neutral position to ensure that all water is drained. This is particularly important following periods of heavy rain. When checking the ailerons, the roll spoiler gauges are also checked. They should indicate 10 degrees at full handwheel movement. That completes the pre-flight checks for flight controls. In the next section, you will complete the pre-flight checks yourself. Pre-flight checks. To begin the pre-flight checks, the position of the air brake lever and the flap lever are checked. You can now complete the following 14 pre-flight checks. Select Auto Spoiler and Lift Spoilers yellow and green on. Test Stall Identification 1. Test Stall Identification 2. Test Stall Warn 1. Test Stall Warn 2. Test the flap safety system. Test the yellow flap control lane. Test the green flap control lane. Full movement and indication of manual and electric trims are checked. To continue, locate the relevant indicators and check they are set to their neutral takeoff positions. Check that the aileron and elevator disconnect handles are in and that the aileron elevator uncoupled annunciator is out. Set flaps to 18 degrees. Complete the configuration test. Which of the following controls has caused the configuration warning? Click on the appropriate flight deck controls or indications to check before making your selection. The pre-flight checks are completed by checking for full and free movement of the ailerons, elevators and rudder. Remember, the full and free checks must not be performed with a tailwind in excess of 10 knots. That now completes the pre-flight checks. The next lesson looks at abnormal operations. Roll control. Aileron disconnect. If an aileron control jam or an uncommanded roll is detected, the controlling pilot must immediately announce roll jam and attempt to regain control. When sufficient force is applied to the hand wheel, the strut linking the two hand wheels will collapse, which in turn will electrically signal the disconnection of the two ailerons. To ensure that the two ailerons are disconnected from each other, this should be followed by pressing in the button in the aileron disconnect handle, and then pulling the handle firmly to its full extent. A successful disconnection of the two ailerons is confirmed by the aileron elevator uncoupled annunciator. If roll control cannot be regained by the controlling pilot, the other pilot should then attempt to regain control. The autopilot should not be engaged following a control surface disconnection, and turbulence should be avoided where possible. The amount of roll control following a disconnect will depend on the location of the jam which caused the disconnect. Roll control will be reduced. However, sufficient control is available to complete the flight safely using normal handling procedures. Roll control may feel different from normal, and circuit friction may be increased. Aileron trim effectiveness may be reduced and should be used with caution. Avoid landing where turbulence or a crosswind in excess of 15 knots is expected. A 24-degree flap landing should be planned. Before landing, a low-speed handling check in the landing configuration should be made to determine handling characteristics. The next section will look at an abnormal operating condition in pitch control. Pitch control. Elevator disconnect. If an elevator control jam or an uncommanded pitching motion is detected, the controlling pilot must immediately announce pitch jam and attempt to regain control. When sufficient force is applied to the column, the mechanism connecting the two columns will split. To prevent the mechanism from reconnecting, the elevator disconnect handle should be pulled firmly to its full extent. The button in the handle will protrude when the handle is fully extended. A successful disconnection of the two elevator circuits is confirmed by the aileron elevator uncoupled annunciator. If pitch control cannot be regained by the controlling pilot, the other pilot should then attempt to regain control. The autopilot should not be used. Control column feel will be different from normal. If the left-hand circuit is jammed, Q feel is not available. And if the right-hand circuit is jammed, the G weight is not available. Avoid landing where turbulence or a crosswind in excess of 15 knots is expected. A 24-degree flap landing should be planned. At a safe altitude before landing, a low-speed handling check in the landing configuration should be made and the neutral trim position marked. A long, straight approach should be made and the previously marked trim position set for the landing. The next section will look at handling abnormalities in the stall warning and identification system. Stall warning and identification system faults. Any operation of stick shake or stick push, with or without the correct indications, must be accepted as indicative of a stall condition. The aircraft pitch attitude must be immediately decreased and thrust increased. Once the angle of attack has been reduced, the operation of the system should return to normal and all indications extinguish. If, however, the stick push is maintained, it is necessary to disable the stall identification system. This can be achieved by pressing both inhibit push buttons simultaneously on either the left or right instrument panels. This will inhibit both channels of the system, and stick push will not be available for the rest of the flight. It can only be reset by ground maintenance action. If the stick shakers remain operating, they can only be disabled by pulling their circuit breakers on the overhead panel. A single internal failure of a stall identification unit will give a stall identification warning on the central warning panel, and the two identification annunciators to indicate which channel has failed. In this case, either of the identification push buttons should be pressed to inhibit the faulty system. When the system has been inhibited, inhibit will light. The other stall identification channel will remain operational, as well as both stall warn units. The final section of abnormal operations looks at a failure of the flap system. Flap inoperative. Flap inoperative indicates a total failure of the flap system. The flaps are locked in position when failure occurs. The flap lever should be set to match flap position. If the flaps are between positions, set the flap lever to the nearest smaller flap setting, and use speeds for this setting. A flap inoperative warning could be due to a flap driveshaft failure, which will lead to asymmetrical deployment. Flap asymmetry will be detected before handling difficulties occur. Again, the flaps will be locked in position. It is vital that asymmetry protection is maintained by keeping the yellow hydraulic system pressurized. Under no circumstances should the essential power supplies be interrupted or the flap computer re-racked. The reset procedure must not be attempted. That completes our look at abnormal operations for flying controls. Limitations. In this lesson, limitation details for the flap extended speed, VFE, and manoeuvring speed, VA, are given for the RJ70, RJ85, and RJ100. RJ70, RJ85, RJ100. That completes the lesson on limitations.